Hello, class. I am going to cover the places where you guys had problems and lost most of your points in Project 2, the blue weed assignment. So first I will show you how to calculate these things, and the most important thing you need in this class is to have Excel downloaded on your computer. If you do not have Excel, then I recommend you get it so that you can excel in this class. Alright, so the first thing I'm going to do is set up my Excel spreadsheet simply by copying this table over to Excel and Control C or Command C, Command C if you have a Mac, which I have, and then Command V to paste it over into Excel. Then we will transfer the information, and most of you guys had the same count as I had for the plants per plot. And if you didn't have the same numbers, I still counted them as correct. However, I would like you to note that according to the instructions and the modules, a plant is counted in the plot if over half of the plant is in the plot, and it is out of the plot if the center of the plant is not in the plot. So we are going to calculate these Design 1 and Design 4 because they are the most different, so that'll make it easier. So the first thing we need to do is calculate the mean plants per plot. And in order to do that, we begin with an equals sign, and that way we click on the cell. Sorry, let's start there. We click on the cell, and then we go up to the top here and we type in an equal sign, and now Excel knows that we want to do a formula that Excel will calculate. The formula for mean is average, so you type in the word average and you click on that. And then you can simply highlight the rows that you want Excel to type an average to, or to calculate an average for. Now, if you don't know the formula that you need for Excel, you can Google it. So if you wanted to know how to calculate an average in Excel, you simply go to Google and say, how do I calculate an average in Excel? And the results will give you this formula. Okay, and so we will do the same over here for Design 4 equals average. Tells you what it needs for that formula. It needs all of the numbers, number 1, number 2, etc. So here we have 10 numbers for our average. And here we only had 5. So that's the average plants per plot. Now we need to do the average density. And so we're going to take our average plants per plot and divide by the plot size. In the case of number of Design 1, the plot size is 1 meter squared. So it's going to be the same. Now let's go to Design 4. It's going to equal the average plants per plot divided by the plot size, which in Design 4 was the large rectangular plots. So that's going to be 2 square meters. It's going to give you how many plants are in 1 square meter, which is 1. Okay. So now to calculate standard error, the formula for standard error is the standard deviation divided by the square root of the sample size. So first we'll calculate the standard deviation. And you could go to Google and say, how do I calculate standard deviation? And the formula is STDEV. Click on that. And we're calculating the standard deviation of the mean density, which in this case happens to also be the mean plants per plot. And in order to get the standard error, it is going to be the formula, and again, this is in your assigned readings. The formula is the standard deviation divided by the square root, which is squirt, and I know that from having Googled it in the past, of the sample size, the square root of the sample size, which is 5. So type in a 5, hit enter, and there is our standard error. Now these values will be different for the large rectangular plots because we are working with density values, not plants per plot. We first need to calculate the density of each plot or of each sample. So let's go ahead and make a new column that calculates design for density. And it is simply going to be equal to the plants per plot divided by the plot size, which is 2 square meters. And I can highlight that and pull this down, and it is going to calculate this value divided by 2 for each column. So again, I'll show you how I did that. So the formula's in there. After I'm done, I highlight the cell and drag it down. So now we're going to calculate the standard deviation for design 4, and it's going to be equal to STDEV. And we're going to now highlight the density rather than the plants per plot. And then the standard error again is the standard deviation divided by the square root of the sample size, which in this case is 10. And I think a lot of you might have made mistakes here and used the wrong sample size. Another common mistake obviously is people calculated the standard error and the standard deviation of the plants per plot. But since we are concerned about density, not plants per plot, that would not be correct. However, if you did that, you were not marked off points because it is very complicated and this is the first time you guys are being exposed to that. Okay, so finally we are going to calculate the confidence interval, which we know it as the minimum range and the maximum range that can be represented as the density. Okay, so there's an easy way and there's a difficult way, and I'm going to show you the easiest way. So again, we'll start with the equals, and we'll type in the word confidence. And we want to do confidence T, because in this class it will always be a T test. And now Excel tells me that we need the alpha value, the standard deviation, and the population size. That's what N means. So our alpha is always our level of confidence, or 1 minus our level of confidence. So if our level of confidence in this case is 90%, which is the same as 0.9, then 1 minus 0.9 is 0.1. So our alpha is 0.1. And again, that information is available in your assigned reading. So you can go back if you want more information on that. Okay, then it says it wants the standard deviation, which we've calculated here. We type that in, comma, and then the population size, which again we know to be 5. And this gives us our confidence interval. So the way we represent this is there are 2 possible ways. One is by starting with your mean density plus or minus your confidence interval, margin of error. And so in this case, it's 1.4 plus or minus. So we got 1.4 plus or minus 1.09. The other way to do it is to take and do this math. Take 1.4 minus 1.09 and make that your lower bound, and 1.4 plus 1.09 to be your upper bound, separating with a comma. you can then say, I am 90% confident that the mean density for design 1 is 0.31 to 2.49 plants per meter squared. Okay, and we can do this for, let's go ahead and do the confidence interval for design 4. So it's going to be equal to confidence dot t, and the alpha again is 0.1. The standard deviation we've calculated here, and our sample size again is 10. Don't forget to change the sample size because it does differ for each sample here. And you can see over here that I had originally miscalculated it, and so that would be it would be half of that, so 0.23. And these numbers will be different. Alrighty. So the other places where people struggled was determining which one was the most accurate or more precise and lending support to those answers. So first, you probably need the definition of accuracy and precision, and that is in our modules. So if you go to module 1, monitoring and sampling, and we're going to click on sampling principles, and then introduction to sampling, and you should all have read all of these things as well as watched the videos, so that's a part of your assignment. And then we're going to scroll down, and here's where it talks about accuracy and precision. So the first question asks, which one was the most accurate? An accurate estimation is one that is closest to the true value of the population, which we rarely know the true value of the population, but in this case, we are given, so here's, you see accuracy there. In this case, we are given the true value of the population. The actual number of blue weeds in the population is 1 plant per meter squared. So we look at our results, and here the density for design 4 was 1 plant per meter squared. So a correct answer would be where you justify it by saying it was nearest to the known measurement of 1 plant per meter squared. Precision, on the other hand, is representing how variable the mean is, or the samples are, from one another. So it's not necessarily how accurate it is, but how variable it is around the mean. So you can have, in this example here, this is very precise because the samples are really close together, but it's not very accurate because they're not actually close to the true mean, which in this case is represented by the target. So what we want to look for is the variability around that mean. And we can go back to our calculations here, and the two values that represent our variability are standard deviation and standard error. In this case, in both cases, design 4 had the lowest, had the greatest accuracy and the greatest precision. And the reason it had the highest precision was because it had the smallest margin of error and the smallest standard deviation. And you do want to refer to those values in your answer. Finally, make sure that when you answer, you justify by referring to the data as well as using complete sentences. Many people did not use complete sentences and also did not refer to the assigned reading. So in the case of the final question, the assigned reading discusses that there's always a trade-off between between plot size and the number of plots, and that was the whole point of this project, was to get you thinking about the trade-off between plot size and the number of plots. So if you mentioned anything like that, you got full credit for that. Okay, please let me and Karen know if you have any questions or comments regarding this. Best of luck.